Hello, ladies and gentlemen, and welcome back. Welcome back. Root Beer here, looking at question number 2 on our 2018 Grade 9 Friar Contest. In the diagram shown, ABCD represents a rectangular field. There are 3 flagpoles, M over here on BC, P on AD, and Q on CD. So they're just flagpoles on the field, I guess. I don't know what these bold lines are for, but maybe if we read on. Paul runs along the path A to D to C to M to A. And Tyler, I'm assuming he's the lower path, runs along A to P to Q to C to B to A. Okay. So we've got 2 light bulbs and a written. We've got various lengths here they don't tell us about in the question, but they're obviously on the diagram. It looks like the dimensions of ABCD is 200 by 105. M is halfway between B and C. And we've got 140 meters and 60 meters telling us where P and Q are. Okay. So, light bulb A. What is the length of MA? So this hypotenuse here, well, we got 100 meters, 105 meters, and it's a rectangular field, so it's going to be a right angle. So just, by Pythagoras. That's a light bulb. You don't have to write anything if you don't want to. Just make sure you have the final answer. So I might say something like MA squared is 100 squared plus 105 squared. And then I don't think, I'm not seeing a... Oh, no, it's 20 and 21, so that is a Pythagorean triple. I just can't... I think it's 29. Well, actually, we can just grab our calculator and check, can't we? But it should be 29 times 20, I believe. 100 squared plus 105 squared is 2125. Sorry, 21025. And so MA is going to be the square root of that. 145. Oh, not 20 times 20. This is 29 times 5, I think. Yeah. Because 100 is 5 times 20, 105 is 5 times 21, and that is a Pythagorean triple, 20, 21, and 29. So, 145, you can write meters, you don't have to. People are really just checking for the numbers. This isn't a physics contest where the units really matter. Units can help you line things up and make sure your equations are good, but you don't actually ever need to write down the units for anyone. Okay, B part. What is the total distance Tyler runs? Tyler is the second person. Okay. Well, let's draw his picture. So 60 meters, 140, 105. This is a full 200. The only thing we don't know is PQ. Now we can fill this in 45 up to, I think this is D. And if it's 140 and a total of 200, then this is 60. This is a 3, 4, 5 triangle. But, and so this is going to be 75, but we can figure it out, again, by Pythagoras. PQ squared is 60 squared plus 45 squared. As long as you have the picture clearly labeled, you don't actually have to explain your calculation of 60, as long as it's correct. Well, I wrote down the numbers the first time, so we'll write them down again. They add up to 5625, and when I square root that, PQ is 75. So that's good. So Tyler runs 140 plus 75 plus 60 plus 200 plus 105. And you can grab your calculator, add that up if you want. 140 and 60 is 200, plus another 200 is 400. Plus 100 from the 105 is 500. The 5 and the 75 go together. So that should be 580, I think. Yep, 580 it is. And so that's going to be our final answer there. And then C part. Paul and Tyler start running at the same time. Tyler runs at a speed of 145 meters per minute. Paul runs at a constant speed and finishes 1 minute after Tyler. Determine Paul's speed in meters per minute. Okay, how do we find meter? We find total distance divided by total time. Okay, we have enough information thanks to A part to figure out the total distance that Paul ran in the same manner that we found the total distance that Tyler ran. But how are we going to figure out the time that Paul took? Well, if we could figure out the time Tyler took and add 1 minute, we'll be all set. So how do we figure out how much time Tyler took? Well, we know from B part how much he had to run and how fast he runs. So there we go. So Tyler ran 580 meters at 145 meters per minute. I don't know if this is going to turn out to be a whole number, so time Tyler took 580 meters over 145 meters per minute. So it'll turn out to be some fraction, and oh, never mind. It is a whole number. It takes Tyler exactly 4 minutes. Yeah, I guess I can see that. The 5 and the 4 would make it 20, and 4 times 14 is 56. Okay, fair enough. So this means Paul takes 5 minutes. And then we've got 100 here, 105 here. I can't remember. It's 200 up on top. What was this? We just had it out. 145. 145. So Paul goes a total distance of 200 plus 105 plus 100 plus 145. And that's 300, 400, 550. So Paul's speed is 550 meters over 5 minutes. And that's going to be 110 meters per minute. So that's our final answer. We've shown each of our steps. Very nice, clean language. If you wanted to add things, I suppose you could maybe add the calculation of the 100 here. I think it's kind of obvious. You might want to add in little things like from B and from A. But I would say it's fairly clear where you're getting these numbers from, so I wouldn't worry too much about it. And there we go. That finishes off question number 2. Join me in the next video for question number 3. I'll see you there, and have a wonderful day in the meantime.